Okay, so here's problem L. And now they're getting a little bit more complicated, but again, it's just a matter of breaking things down into simpler steps. So that here's AZ. Now look at the expression on the right, and if you kind of step back for a minute and look at the big picture, you can see that it's the product of two functions, and each of those functions is a composite function. So when you break it into smaller steps, you start with the big picture first. So this is the big picture, and we're looking at the product of two composite functions, so we're going to do the product rule first. But before we do that, we're going to define some new functions just like we've done before. So let b of z equal secant of 4z. Okay, and c of z equals tangent of z squared. Okay. So the big picture again is a prime of z equals, since the product rule, remember, so it's going to be, depending on how you like to do it, let's say b prime of z times c of z plus b of z times c prime of z. Okay. So we've already defined what c of z is and b of z. We just have to find b prime of z and c prime of z. And now we're into composite functions, which is the main point. So now let's look at b prime of z is the same thing as d b of z dz. But to get there, we're going to define a new function. Let u equal 4z. So then b prime of z now equals d b of z du times du dz. Again, I know I'm doing it right because these two du's are going to cancel out. So what's d bz du? Well, if u equals 4z, then now bc equals the secant of u. And what's the derivative of the secant of u? I don't remember. I'm going to look it up real quick here. It's equal to secant x tangent x. That's interesting. All right. Well, okay. So dbz over du equals secant u tangent u. All right. And du dz, that's easy, that's just 4. So if we multiply this factor and this factor, we find that b prime z equals 4 secant u tangent u. And of course, u equals 4z, so you could substitute back in for u with 4z. I'm not going to do that right now. That step is easy, and that'll give you b prime of z. Okay, so when we multiply, when you substitute back in for u and you multiply b prime of z times c of z, you're going to get the first term of this expression. And so you can see all we need to do now is find c prime of z. We'll do that on the next page, although you could probably do it on your own. But just for fun, just to reinforce the idea that we have a fixed protocol now, you could say. We have a recipe for doing this, and it's just a matter of repeating the same formula, the same algorithm. Algorithm would be the right word. But let's find c prime of z. Okay, so new page. C prime of z equals, let me make sure I get this right, c of z equals tangent of z squared. Okay. Tangent of z squared. Good. Okay. So let u equal z squared. And let's just go ahead and differentiate du dz. That's easy. That's just 2z. Okay. And then what is dcz du? Well, cz now equals tangent of u. And so this derivative equals secant squared of u. We found that out earlier. So once again, make sure we're on the right track. Let's write it all out. So dcz over dz equals dcz over du times du dz. And we know this factor and this factor now, it's just secant squared u times 2z, and we substitute back in for u. So that's interesting. We're going to get 2z times secant squared of z squared. So now we have an expression for c prime of z. And you would just go back and plug that in here. And then multiply all of that out. Simplify it if you can. If you can't simplify it, don't worry about it too much, because you've essentially done all the hard work. All right, that's problem L.